Amazon Simple Queue Service, or SQS, is a fully managed message queuing service that allows us to decouple applications and build distributed systems. Using SQS, you can send, store, and receive messages between applications without losing them or needing the other applications to be online. In this video, let's learn how to get started with Amazon SQS and use it from a .NET application. We will learn how to send and receive messages and different properties and concepts you need to know when using SQS. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos on .NET, Cloud, and DevOps. Without much delay, let's jump straight into learning Amazon SQS, or Simple Queue Service. I have Visual Studio open and I have created a default .NET Core 6 Web API template. As you can see here, it has the program.cs, the weather forecast.cs, and also a controller, which is the weather forecast controller. This is the default template, and this class has a get method which currently returns a bunch of dummy data. Now, let's say we want to add a post endpoint to this controller and start processing weather data. Now, processing of weather data could be a time-consuming activity, so we might want to decouple this into a different process. In these cases, you can accept a post message and push this onto a queue. Now, if you're building on the Amazon AWS ecosystem, SQS is the perfect choice for this. This gives a fully managed queuing service where you can send these messages and process it at a later point of time. So let's start adding a post endpoint. So very similar to the HTTP GET, we can add a HTTP post and specify the method. So in this case, it's going to be public. It will be a task and a synchronous process. And let's name this as post. This will take in the exact same data. So let's call this weather forecast and have this as data. Now this is going to come in as part of the body and we can process it inside here. With the data available here, we can drop this into a queue. So let's create an Amazon SQS. Amazon Simple Queuing Service offers secure, durable, and available hosted queue that lets you integrate decouple distributed software systems. This is exactly what we want in our case because we want to decouple the taking of a weather data and the processing part of that data. Now, SQS supports two types of queues. One is standard and the other one is FIFO queues, which is first in, first out. In this case, we will be exploring the standard queues. We will look at FIFO queues in a different video. Now, there are many benefits of using Amazon SQS. You can look at some of these in the documentation here. I'll make sure to put this link in the description below. Another important thing to keep in mind is pricing. What does it cost to use an Amazon SQS? With Amazon SQS, like the other cloud services, you would be only paying for what you use, and there is no minimum fee. And also you can get started for free because there is a 1 million request that you can make for free. Now for this purpose of the demo video, I am using the AWS free tier, which is completely free to try it out on your own account. If you're using this in a production workload, then you can look at this pricing calculator and see how much it would cost you. Let's head over into the AWS console to create our first queue. Now here I have the Simple Queue service under my recently visited, or you can also search on the search bar for SQS and select it from there. To create a new queue, let's click the Create Queue button. This prompts you for a name, so let's give this a name. In this case, let's call this YouTube-demo. Now here, you can see there is an option between the standard and FIFO queues. In this case, I'll keep this as standard. Note, you cannot change the queue type after you create a queue. You will basically have to create a new one. Now, if we scroll down, you can see a lot of default configuration here, which we will come to later in this video. Let's leave this as default and see what each of this means later. This also defines the access policy, which is basic and currently gives access to the owner, which is myself in this particular account. Let's ignore all these other which are optional properties and leave this as default and click Create Queue. This will create a new queue which will be available in our queues list. So if we navigate back to queues, you can see YouTube demo in the list here. So let's come back and start using this queue from our application. Let's come back to Visual Studio and create a new client to send the message to the queue. So we need to create an instance of Amazon SQS client. So let's name that. And this will come from a NuGet package. So if you press Alt Enter or Control Dot, you will get the option to install the latest version of AWS SDK.SQS. Now in this case, Visual Studio has gone and done a type-based search inside the NuGet library, which is how this suggestion is coming up. So let's do find and install the latest version, which will automatically install the NuGet package. You could also go into Manage NuGet Packages and install this package explicitly. So once this is installed, let's create this instance. This class has multiple constructor overloads. In this particular case, let's use the one that takes in the credentials and the region. So let's use credentials, comma, and specify the region endpoint that this is using. So let's say region endpoint. Make sure to include the missing using statement, which is from using Amazon, and specify Southeast Asia too. This is my default region for the account and where I had created this queue. You can drop this down and see the region names, which is AP Southeast 2. So let's come back. Make sure to create this credentials class. So let's use var credentials is equal to. In this case, let's use the basic AWS credential, which will take in an access key and the secret. So again, let's make sure to make the appropriate usings and pass the access key and the secret key to it. We will get this in a moment. Now, for this demo purposes, I am hard coding the credentials here. In a real world application, you can move this to a more secure storage. I have a video which walks through 5 different ways on how you can manage application storage when building .NET applications. Let's make sure to name this as credentials. Now, once we have the client, we can use this to send a message into our queue. So let's use the client.sendMessageAsync. Now, there's also a send message batch async, which allows you to send multiple messages. So let's just stick with the message and send single message. Now, this method again has multiple overloads. We can use the one that uses the send message request. So let's define a request. Make sure to come ahead and create a new request, which is going to be a send message request. This again comes from a different namespace. So let's make sure to include it from sqs.model. The basic properties you want to set on the request is definitely the queue URL, which will be the URL to the queue that we are sending to, and also the message body, which is the body of this particular message. In this particular case, we want to send this weather forecast as part of the body. So we can use a JSON serializer, which is by default available. So let's use JSON serializer, which comes from the system.text.json, and call the serialize method and pass this the data, which is the weather forecast in this particular case. So this creates the send message request, sets up the body and sends it to the client. Now for the queue URL, let's navigate back to the queue that we have created, and you can copy this URL from here. So this basically forms a convention where it says sqs.the-region, your account number, which is available from the drop down here, and you can see the account ID and also the queue name, which is YouTube-demo. So let's copy this, come back and use this inside our queue URL. The send message async is an asynchronous method. So let's add an await onto this particular call. So we can call back await and also specify this method to be asynchronous. So it automatically adds the async keyword. With all that said, let's go ahead and create our basic AWS credentials so that this application can talk to SQS. Let's come back to our AWS console. Let's open this in a new tab and navigate to IAM. So here we can create a new user and get the credentials and give it access for this SQS queue. So let's come into users and create a new user. In this case, let's name this as YouTube-SQS-user and select access key programmatic access because we want the access key ID and the secret access key. Let's click next. Let's come back and add the permissions later. So let's say next on the tags and click next review and create the user. Currently there's no permissions. We will create that shortly. So let's show this secret access, copy this key, and also let's copy the access key ID. Now both of them are available on my clipboard. So let's come back to our basic credentials, paste in the access key ID. Now if I press Windows and V, I can get the clipboard and paste the secret as well. So let's put that there. Now let's come back to our console and add permissions to this newly created user. So let's go back into the YouTube SQS user. Under permissions, let's add an inline policy. Here we can explicitly select a service. So let's search for the SQS service, which is what we are trying to give access to. Let's give all SQS actions. Now based on your application, you might want to pick and choose whether it's a read, tagging, write, or the permissions management that you want to give. Now for this demo, I'll just stick with all permissions. Let's specify the queue that we created. So let's select specific and add the ARN of that particular queue. Now in this case, let's come back to SQS, copy the ARN from here and come back and paste it inside here. This will automatically populate all this. This basically is the combination of the region, the account, and the queue name. Let's click add. Now this has the full access on this queue. So let's do review policy and give this a name. So let's say YouTube demo SQS policy and create policy. So this creates the new policy and the user has access to our YouTube demo SQS. So let's come back to our Visual Studio and run this to see this in action. Our application is running. So we have the get and post endpoint in the Swagger UI, which is by default set up with the ASP.NET API template. So let's click post, say try it out and select execute. This by default has the weather data in the body. So let's click execute, which hits our breakpoint. Now we have the data that we have just sent as part of the request. So let's step over this. It creates the credentials and the client, and it creates the request object and drops this into the queue. Now this is successfully processed. So we have sent this message into our queue. So let's navigate back into the SQS and look at send and receive messages. So once you click that, you can poll for messages in the UI here. You can also send messages directly from here. So let's click poll for messages, and this shows the one message that we just received. So if you go into this, you can see this has the exact content that we have sent from our application. Now this is for 2022-2/15, and if we come back into the Swagger UI, you can see this is exactly the same. So we were able to successfully send a message from our web API into our SQS queue. Now let's come back to our Swagger UI and let's update this summary. Let's say new message and hit send again. Now this is again going to hit the breakpoint and send the message into the queue. So if we come back here and say poll for messages again, you can see this has two messages. These are the two messages that we just dropped. Now, every time we click the poll for messages, it receives the messages from the queue and shows it here, which is why the receive count keeps incrementing every time we receive the message. Now, after dropping the new message, I only clicked poll once, because of which the receive count is 1. Now, whenever I clicked execute, it immediately dropped the message into the queue. In certain cases, you might want to add a delay onto this message appearing in the queue. Now this might be cases where you want to delay the processing of something. Let's say you want to send a notification, but you want to delay it, let's by X minutes or seconds inside the queue. In these cases, you can use the delay seconds property. So if we come back into Visual Studio, let's stop this. When we create the send message request, we can specify the delay seconds property. Now this is the length of time in seconds to delay this particular message. Now the values can be from 0 to 900, which is basically 15 minutes. So in this particular case, let's say delay seconds and put 10 as the delay. Now every time this message is sent, it will appear in the queue only 10 seconds later. So let's see this in action. Let's run this again. Let's go to post, click try it out and update the string to say delayed message and say execute. Now this is going to drop this message into the queue. So if we come back to the queue immediately and say poll for messages, you will not see this message appear immediately. Now this is going to appear in the queue only 10 seconds later. So once the delay seconds of 10 is over, you can see this message in the queue. So now if I come back again here, you will see that this has appeared here. Now if you go into the YouTube demo queue, You can also set the delay at the queue level. So if we click edit, we can see one of the properties that we saw when we were creating the queue was delivery delay. So if you click the info, you can see the information here. So it's basically the additional time to process. You can delay each message coming to the queue. So this applies to any message that gets dropped into this queue. Now you could set this value between 0 and 15 minutes, which is exactly the same as that is available on the message. So if you apply it on the message level, it's applicable only for that particular message. And if you apply it at the queue level, it's applied for all messages coming into this queue. Let's leave this as 0 because you know how exactly this will work. So let's come back to Visual Studio. Let's stop this and let's also comment this out. Now that we have messages coming into the queue, we need to start processing these messages. Now there needs to be a separate process or a component that can pull these messages from the queue and process it in the background. This could be a background service, a AWS Lambda, or any other process that can access this particular queue. In our example, let's create a background service. Now, if you're new to .NET Background Service and want to learn more about it, check out the video linked here or in the description below. So let's come to Solution Explorer. Let's create a new class. So let's call this as Weather Forecast Processor and click Add. This creates a new class for us. Let's inherit this from background service so that this can be used as a background service. Now this is an abstract class, so let's make sure to implement it by using Alt-Enter and click Implement Abstract Class. This adds in the task execute async method, which is kicked off when this background service is started. So let's start by writing a console statement saying console.writeLine and say starting the background process. Now since we need to run this in a loop and keep polling for messages inside our queue, we can use the cancellation token that is passed in. So we can use while and specify the stopping token and check if this is cancelled or not. Now we need to keep looping this until cancellation is not requested. So let's make sure to add in a not here. Now this again needs to connect to the queue. So let's come back to our controller. Let's copy these 2 lines of code and paste it inside here. So let's keep this outside of the loop because we just want one client to be created. Let's make sure to include all the usings. So let's do that for each of these types and start using this client to poll for messages. So let's say where response is equal to, let's use the client dot receive message async. Now this again has multiple overloads. So in this case, let's create the one that takes in the receive message request. So let's specify the request and define the request above. So let's say where request is equal to new receive message request. Now this again comes from a different namespace. So let's include that and make sure to pass in the required properties. Now this has the queue URL, which is the queue that it needs to receive the messages from. So we already had this in our controller. So let's copy this and paste it inside here with the new property. So once this request is created, let's receive the messages from here. Now since this is an asynchronous method, let's go ahead and add the await. Now with the await, let's make sure the method is also async. So with the response, we can start looking at the response and see what it contains. So this has the messages property, which is going to return all the messages in this particular request response. So let's loop through these messages. So let's add a for each where message in all these messages and simply log this out into our console. So from the response.messages, we are looping through each of these messages and saying console.writeLine, take in the message, which is the independent message, and write the body to the console. We have the background service, which looks at the queue and writes it into the console. So let's go into the program.cs and register this background service. To do that, let's use builder.services.add hosted service and specify the background class, which in case this is the weather forecast processor. So once that's added, let's make sure to include the appropriate usings and close this brackets. Now this is going to create an hosted service and register our processor as a hosted service. which will run as a background service. This will run along with the web API that we have running otherwise. So let's put a breakpoint here and run this application. Now the background processor has started, the breakpoint is hit, so this is going to loop through until the cancellation is requested, which is basically when we shut down the application. Check out my video on background process if you want to learn more. So let's continue the execution. So this opens the Swagger UI, and if you go back to the host command line application, you can see this also is starting the background processor. Now we had 3 messages in our queue, so this has got all 3 messages and logged it into the console. So you can see the summary is different for each of these messages, which says new message, delayed message, and also the default one that we sent first. Now if we come back to our application, let's see how many times this is looping through and getting the messages. So let's add a new console line and specify this as getting messages from the queue. So this will be logged each time it is going through this loop. So let's run this and see what is happening. Now if we open the command line, so the message processor is started. It is again getting these messages, and you can see this is keeping on polling for this queue. Now it's calling this every time it completes that particular request, it keeps on calling continuously. Now for your background processes, you might not want to call this often. You might want to call this with a slight delay. You could add a delay after this whole for each statement. So you could specify a task.delay in here and make the whole process wait before it goes into its own loop. But even better, you can specify the wait as part of your request itself. So if we come over here, we can specify wait time in seconds and specify a value here. So let's say we put 10, which is going to wait for 10 seconds. Now, by adding this property, we have enabled long polling. Amazon SQS provides short polling and long polling to receive messages from the queue. By default, it uses short polling, which is when that property was 0. Now, when you're using short polling, Amazon samples only a subset of its servers based on a weighted distribution and retrieves the messages that it can immediately find. So it doesn't wait to find messages in all these distributed servers. Now, even though it has all these messages, it only returns a subset of that message inside this particular request. Whereas when you use long polling, there is a maximum wait of 20 seconds, but basically it looks at all these message services and returns back the data. Now some of the benefits of using long polling is that it reduces the empty response. So if you make a request and it doesn't have a message immediately, it waits for some time before returning the response. You also reduce the false empty responses because it waits and queries all the servers that could have the messages. With long polling, it also returns the messages as soon as they become available. Now, with that property in, let's run this and see how the polling is working. The background processor has started. It has again retrieved the 3 messages that we had dropped, but you can see the get guest messages from the queue is now delayed. If we want, we can also come back and add in a date time so that we can see how much time is getting between each request. So let's use string interpolation and specify datetime.now. Let's remove this breakpoint and run this again. So it starts the processor, it starts getting the messages at 5:05:48, and this is going to make another request soon after 10 seconds. So you can wait for 10 seconds and it will make the next request. So you can see the next request is at 56:01. So now we have successfully introduced long polling inside our queue consumer. So this will keep polling, and as soon as message is received, it will return back and log this message here. So let's come back and let's comment this out. You can also specify the wait time in seconds at the queue level. So if we run this again, we can see this in action. Now, as you can expect, since we removed the wait, it is going to keep polling with the short polling. So let's come back to our SQS, go to our queue. Under the configuration, we can update the receive message wait time. Now, the receive message wait time is the maximum amount of time that polling will wait for messages to become available to receive. So in this case, you can again specify a value between 0 and 20 seconds. So let's make this as 10 and click save inside this queue. Now this gets applied for all this queue. So anything that is receiving the message we'll have to wait for 10 seconds. So let's come back here. As soon as that kicks in, you can see this will get slowly delayed. Now you can see this has stopped polling at 5, 8, 10, where it was continuously polling every second, and now it's become every 10 seconds. As soon as a message becomes available, it returns back. So now since we got these 3 messages, it will now continue it every 10 seconds. You can see this request was made at 28 and the next one at 38. And the one after would be at 48 and so on. Now you can see that these messages keep coming back into the queue after a certain delay. Now this is the visibility timeout. So if we come back to our code, we can specify the visibility timeout. So if we look at the request property and use the visibility timeout, this again can be set a value which is in seconds. The visibility timeout is the duration in seconds that the received messages are hidden from other retrieve requests. So this gives the message to a particular consumer to process it and hides it for everybody else. So if you have multiple background services or scaled up servers that is processing messages from the same queue, it will avoid duplicate processing of the messages. So every time it delivers a message, it starts a timeout and keeps it available into the queue again after that timeout. So let's specify this visibility timeout, and let's say this value is 20 seconds and run this. Now the background process is running and it has started this. So this has started getting the messages from the queue. It's got all these 3 messages and it will now wait for 10 seconds because of the delay in the wait period. After that, it will poll this again, and at that time, the message has not yet appeared because the delay is at 20 seconds. So once the message comes back again, it will give us that messages again. So every time it reads for that visibility timeout duration, it will not be available for other consumers. Same with visibility timeout, you can also specify inside the queue level. So if you click this edit, you can specify a visibility timeout. Now by default, the visibility timeout is 30 seconds, which means the message will be hidden from the queue for every other receiver for 30 seconds once one receiver has read it. Now in these examples, we've been seeing the same message come over and over again when we run this background process. Now this is because we need to explicitly mark these messages as deleted to successfully complete the processing. Otherwise, the queue thinks that there was an error processing this particular message and makes it available again in the queue after the visibility timeout period. To avoid that, let's go and explicitly delete these messages. So let's come back into our code. Once the processing is complete, in this case, this is simply writing to the console.write line. So let's call the client.delete message. Now this again takes multiple overloads. You could pass this a delete message request or pass in explicitly the queue URL and the receipt handle, which is coming from the message itself. So let's look at the message dot receipt handle and pass that in. For the queue URL, let's copy and paste this, which is the exact same queue. So let's delete this message with the await in here. So every time a message is processed, it's going to delete it from the queue. Now, if you want to control the number of messages that comes in each response, you can also do that using the maximum record number. So you can specify the maximum number of messages and give this a value. Let's leave that as the default for now. Let's run this to see the delete in action. So this is again getting the messages. This will again get the 3 messages that we have in the queue, and this will be deleted successfully. Now you can see, because the maximum messages is on the default, which is 1, it is getting only 1 message per request. So you can see that it is running the getting messages from the queue every time, and it logs only 1 message, even though we are doing a for each. Now if we increase that, you will be getting multiple messages. Now this processor is continuing to execute, but these messages haven't come back. This is because we have explicitly deleted it after processing. Now let's say some messages we are not able to process successfully. Now this could be because of a business error or also because of network connectivity issues connecting to other services and infrastructure. Now in these cases, we can mark these messages as not deleted because it would not have successfully processed. So let's assume in cases where the message.body.contains the word exception, we can think this is going to throw an exception. So let's say exception. And in this case, we can simply continue this for loop and not mark this method as deleted. Now you could throw an exception here, but this would also bring down the whole background service. So you will have to try catch this and throw an exception inside that. But for now, I'll simply use continue so that it doesn't delete this particular message. So let's run this and see this in action. We have the application running. So let's reduce the size of it so we can see both of them in one screen. Let's click the post. Let's click try it out and simply send a default message. Now this is going to get picked up and processed successfully. It did not have exception. It deletes the message from the queue and it is no longer available. So let's come back here and say this has an exception. So this processor is going to look exactly for that word and continue that particular execution. So let's come back and click execute. Now this has successfully picked it up. It says it has an exception, so it does not delete that particular message, which will make it available after the timeout that we had specified, which was 20 seconds. So after 20 seconds, you can see this message has successfully reappeared in the queue, which again contains this exception. Now this will continuously loop through this and keep putting this message back into the queue until this was solved. Now in this particular case, since this was hard-coded here, this message is always going to throw an exception. But if it was a network connectivity issue or some other server down when you were trying to process it, when you retry this message, it will automatically get passed sometime later. But if you have a lot of messages erroring out and into the queue, your queue might soon be filled up with these error messages. And especially if these error messages are not something that would solve on a retry, you would be unnecessarily wasting your processing power. So you would be looking at the same message again and again. To avoid this, we can add in the support for dead letter queues. Now the dead letter queue is another queue that will be associated with the main queue, which is to move dead letter messages. So anytime you find a particular message cannot be processed, you can move this into a dead letter queue. Let's see this in action. So to create a dead letter queue, let's come back to Amazon SQS. Let's go into queues and create a new queue. So let's click create queue. Let's name this as YouTube-demo/dead letter queue. I will use DLQ as a convention. Let's leave everything else as the same. So this is exactly a queue that we saw before. So we could keep this as a standard as well and click create. Now once we have the dead letter queue created, let's come back to our queues, go into our original queue and associate this dead letter queue. So if we click edit and scroll down, you can see one of the policies here is to assign a dead letter queue. So now currently this is disabled. So let's click enabled and choose a queue from here. So in this case, let's choose the YouTube demo DLQ that we just added. Now once you specify a dead letter queue, you can also specify the maximum receives. This is the maximum number of time that a message can be received by you before it gets moved into dead letter queue. Now by default, it has the value of 10, which means the same message will be delivered to you 10 times before it automatically moves it into the dead letter queue. So let's reduce this and see this in action. So let's make this as 2 and click save. Let's come back to our application and run this to see this in action. Now we have the application running. So let's go to the post weather forecast. Let's say try it out and select this message. So in this case, let's specify exception, which is going to throw the error. So let's click execute, which is going to drop the message. It's got picked up by the queue and it's tried to process it. But in this case, since it contains the exception, this will not delete that particular message. So after the default visibility timeout, this message will again become available to us. Now you can see that this message got delivered again, and this is the second time this message was delivered. Now even if you wait after the visibility timeout, you're not going to see this message again, because when we specified the dead letter queue, we set the count as 2, which means after 2 tries, it will automatically move it into the dead letter queue. To see that, let's navigate back to our SQS queues, go to queues and go to the YouTube demo dead letter queue. So let's refresh that and select it. Now in here you can do send and receive messages, come down and say poll for messages. Here you can see these two messages have come here. The first one is the first error message that we tried, and the second one the second time. Since the first one had already been retried more than 5 times, it automatically moved it into the dead letter queue the moment we created the dead letter queue. Now, depending on your application, you can set the number of times a message needs to be retried before it gets moved into the dead letter queue. Another way a message can come into the dead letter queue is when the message gets expired. Now, if you come back to queues and go into YouTube demo and click edit, you can see the message retention period property. Now, this is currently defaulting to 4 days. Now, this could be between 1 minute and 14 days. Now, what this indicates is the amount of time the queue will retain this message in this queue. So, looking at the first time it has seen the message, it will wait for 4 days before it automatically moves it into the dead letter queue. So, if you have the weather processor service down and it's not processing the message, and after 4 days, these messages will automatically go into the queue. Also, if it is a lesser value, and depending on the number of retries that you have, you would either get a message expired and move to dead letter queue, or it would move because it has exceeded the maximum number of retries. So you can use the dead letter queue to monitor the messages that are not getting processed and reprocess it from there, or also look at your business process and see what the error is. I hope this helps you to get started with Amazon SQS and start using it from a .NET application. We have seen how to send and receive and some of the basic concepts of the queuing system. Now, if you're familiar with Azure, the equivalent of that could be the Azure Storage Queues or also the Azure Service Bus Queues. If you want to learn about that, you can check out my Azure series, which will be linked here. If you have any feedback, comments, or questions, always drop them in the comments and I make sure to reply to them. If you want to be notified of future such videos, please make sure to hit the subscribe button. It also helps me to grow this YouTube channel. Thank you and see you soon.